Hi everyone, this is Hassan and welcome to my channel, Hassan Academy. So today we are going to discuss one more concept, and this concept will help you in your JEE or NEET exam. Okay, so if you are a JEE or NEET aspirant, you should subscribe my channel, share with your friends so that I can make more and more video. So concept is how hydrogen bonding affect acidity of different molecule. Okay, whether hydrogen bonding is increasing the acidity or decreasing the acidity, and which type of hydrogen bond affect mainly, it is intramolecular hydrogen bond or intermolecular hydrogen bond. About that I will give you one concept. Okay, if I want to say in one line answer that hydrogen bond sometimes can increase the acidity, sometimes can decrease the acidity, it is based on the molecule, which molecule we are talking about. Okay, let's come to the point. uh, Effect of hydrogen bonding in acidity. Okay, concept of hydrogen bonding in acidity. Okay. Simply you can write a small heading like that. So first of all, I will show you where hydrogen, due to hydrogen bonding, acidity is going to decrease. Okay, this is what phenol. Yes, I keep ortho position nitro group. Let's take this one. Okay. Then I will keep another phenol. But now para position I will keep nitro group. Okay, I can write NO2 also. Anyway, so orthonitrophenol, this is paranitrophenol. Now, if you don't know this hydrogen bonding concept, what do you think that phenol, ortho position nitro group, para position nitro group. This one will show minus I, this one will show minus M. This one will show minus I, this one will show minus M. Now, you know one thing, that mesomeric effect, whether it is ortho or para, doesn't matter, distance doesn't matter, it will show equal amount. So, this minus M and this minus M is constant for both the compound. Okay, but where difference is coming, this is in ortho position more near means more powerful inductive effect, minus I effect, but this one is para of that this phenol group, OH group. So this minus I is very small amount. Yes, very small amount. Okay, compared to this minus I, this one is small. Okay, due to the distance, since inductive effect is related to distance. So, and if you know this much, then you can conclude that this minus M is constant, but minus I is more here. So first compound is more acidic than the second one. Done. So this you will go for acidity, but originally that is not the case. Okay, if you go for orthonitrophenol is more acidic than paranitrophenol, then you are going to mistake. You will lose some mark. The original answer is paranitrophenol is more acidic than the orthonitrophenol, even though their difference is very negligible, not negligible, very less. Okay, this is 7.2 pK, this is 7.16, or some books writing 7.1 pK, even though 0.1 difference is there, it is there. Okay, so now you have to understand the original reason behind that why orthonitrophenol is less acidic compared to the paranitrophenol, even though if you go for electron movement effect, then you are going to get your answer that ortho should be more, but that is not the case. So you should understand how hydrogen bonding effect here. Okay, so minus M effect I am going to remove from here, because with this you are going to get the wrong answer. So now you have to understand another thing, that this OH hydrogen is obviously delta plus, but this oxygen is delta minus. Okay, this is delta plus and this is delta minus. Now this delta plus and delta minus, this hydrogen can make the hydrogen bond here, intramolecular hydrogen bond. No doubt this molecule also participate in hydrogen bonding, but that is intermolecular hydrogen bonding, another molecule required. But here within the molecule itself they are going to make the hydrogen bond. Okay, so intramolecular hydrogen bond, since they are already molecule once exist, they exist with intramolecular hydrogen bond. Now what is acidity? Removing a proton. Now remove this proton from here in the form of H plus. It's little bit more difficult compared to this one. Why? Because they are already bonded with hydrogen bond. Okay, that is one of the concept, that since it is intramolecular hydrogen bond, due to that hydrogen bond removing H plus is little bit difficult, so it is pKa little bit higher than this one. Okay, so this is, if you go for acidity, this one is more, this one is less. Okay, their pKa value, this one is 7.2, This one is, let's go 7.1. You can say 7.16 also. 7.1. Okay, so you got to know due to hydrogen bonding what happened, acidity decrease. Okay, one concept. Now we will go another example where acidity increase. Okay, you can take the screenshot. This is one of the example. Okay. There are many other examples also, but one example is more than enough. Now we will go for some molecule. Let's go for benzoic acid. Okay, I am going to write benzoic acid. This is okay. Benzoic acid. Benzoic acid pKa, you know, it is around 4.2. It is very good strong acid. Okay. Now in ortho position, I am going to give you OH group. Okay. Now if you go for their pKa value, that will be lesser than 3, 2.98, 2.97 around, or you can say even 3. Okay. But 3 pKa is quite more acidic than the 4.2 pKa original in benzoic acid. Okay. So here acidity is increasing. Okay, almost 10 times increasing, more than 10 times. Okay, even though one difference coming in pKa value, that is going to the 10 to the power. Okay, so here you have to understand one thing, that between COH and OH group, COH group is more acidic. Okay, this is more acidic group than the OH group. Now since it is more acidic group, obviously it want to remove that H plus. Okay, COH will remove the H plus so that it can get CO minus. Suppose I have removed from here proton and I got one O minus. Once I got O minus, this O minus and this hydrogen can make very good hydrogen bond. Since after removing the proton, they are going to get the very good hydrogen bonding, so they prefer to remove the hydrogen and making their own hydrogen bond, intermolecular hydrogen bond. That's why this pKa is decreased, because after removing proton, conjugate base is more stable. Got it? So in this one of the example where due to the intermolecular hydrogen bond, acidity is increases. Okay, many one may think that sir, it is benzoic acid, ortho position is there, ortho effect. No, OH is not going to show the ortho effect. OH, NH2 and CN, these are the, even fluorine, these are the so teeny group that they are not going to show the ortho effect. This is not because of ortho effect. Okay, if I give here benzoic acid and ortho position R group, alkyl group, then definitely that is because of R group, ortho effect is coming, and due to the SIR effect, steric inhibition of resonance, that acidity is going to increase. That is separate, but here ortho effect is not the concept. What is the concept? Intramolecular hydrogen bond. Intramolecular hydrogen bond. Okay. Okay. Now I can give you salicylic acid. This is orthohydroxybenzoic acid, is salicylic acid, orthohydroxybenzoic acid. But if I give you in both side OH, now this one can make hydrogen bond in both sides, and this one is more acidic than this one. Okay, so this is the concept. If hydrogen bond only one side possible, then definitely it is acidic compared to the benzoic acid. But if I give OH in both sides, then this one going to be more. If you ask me how it is possible, it is possible because this is going to be O minus, and if it is do the resonance, you know they are doing the equivalent resonance. Yes, equivalent resonance, and due to that this will get delta minus, this will get delta minus half, just divide it half, and this hydrogen is here, hydrogen is there, this hydrogen is there, they are going to make the hydrogen bond. Okay, so this one more acidic compared to this one, and this one more acidic than benzoic acid. You can take the screenshot and you remember this is the one of the concept where due to the hydrogen bonding, intramolecular hydrogen bonding, acidity increasing, and orthonitrophenol is one of the concept where due to the intramolecular hydrogen bonding, acidity decreases. Hope you got it. Thank you for watching and keep sharing with your friend. Thank you.